Welcome to Chapter 8, Rescue Equipment. In rope rescue operations, the type and condition of your equipment isn't just important, it's critical. The right gear, in the right condition, can mean the difference between a successful rescue and a preventable accident. NFPA 2500 provides baseline standards for rescue gear, giving us a framework for safety and performance, but remember, the authority having jurisdiction always has the final say on what equipment is appropriate for a particular operation. When we talk about carabiners, screw links, braking devices, rope grabs, anchorages, and pulleys, we're talking about the essential tools that make rope rescue possible. A well-structured rope rescue equipment program ensures every piece of gear is properly suited for its task, fully functional, and safe to use. Such a program also helps us identify which equipment requires more experience, which needs refresher training, and which must be retired before it becomes a hazard. Understanding your equipment, the hazards, and the safety implications is key to performing rope rescue operations safely and effectively. So let's get started and take a deep look at the tools that keep us and those we rescue safe out in the field. Alright, let's dive into talking about rescue equipment. When selecting gear for rope rescue operations, there's more to it than just picking what looks strong or shiny. The choice of equipment depends on several key factors, both organizational and occupational. On the organizational side, we're talking about operational pre-planning, hazard analysis, staffing levels, and training programs. These are the foundation that help us understand what gear will be needed and how it will be used safely. On the occupational side, we need to consider the types of incidents likely to happen in our jurisdiction, the hazards we might encounter, the number and qualifications of rescuers available, and the standard operating procedures that guide us. Training frequency and type also play a huge role in deciding which equipment is appropriate. Once the right gear is selected, it's not enough to just throw it into a bag. We need to think about organization and deployment. Gear should be labeled, color-coded, pre-configured for operations, and packed thoughtfully so it's ready to go the moment we arrive at the scene. Every second counts in rope rescue, and a streamlined system makes all the difference. Agencies should develop a formal program for selecting, maintaining, and caring for life safety rope and all related equipment. And for that, NFPA 2500 is an excellent resource. It builds upon previous standards like NFPA 1858 and NFPA 1983 and provides clear guidance for establishing criteria on the selection, inspection, and care of life safety rope and associated equipment. So, by following these principles, we make sure our team is ready, our gear is ready, and our rescues are as safe and effective as possible. Let's continue and take a closer look at how all this comes together in practice. Let's talk about the Rope Rescue Equipment Program. A well-structured equipment program isn't just paperwork, it's the backbone of safe, effective rope rescue operations. The benefits are clear. First, it ensures that all life-saving equipment is ready and available when it's needed most. Second, it provides guidance through standard operating procedures, or SOPs, which give every rescuer a clear understanding of how equipment should be selected, inspected, maintained, and stored. By having a program in place, we create consistency, increase safety, and make sure that no piece of gear is overlooked. Properly managed, the program ensures every rope, carabiner, pulley, and other critical piece of equipment is safe, functional, and ready for the task at hand. Now let's move on to equipment records. Keeping detailed, accurate records is a cornerstone of any rope rescue equipment program. Because equipment is only as reliable as the information we have about it. Each piece of life safety rope and rescue equipment should have a record that includes equipment identification and manufacturer guides, date of purchase and date placed in service, location of service and manufacturer model details, dates of use, including circumstances like weather conditions or any potential damage, dates of cleaning and inspections, and if retired, the removal from service date. Color coding and labeling are also essential. These visual cues can identify ownership, service location, duty assignment, or which vehicle or cache a piece belongs to. Finally, organization and storage should follow a logical sequence for deployment. Gear should be grouped by functionality, anchor kits, lead climbing kits, patient restraint kits, and pre-rigged for rapid deployment whenever possible. Proper marking, labeling, and pre-rigging make every second count during a real rescue operation. Selecting rope rescue equipment starts with a clear understanding of the types of incidents your organization might face. Consider environmental factors, incident locations, steep or vertical terrain, and the frequency of incidents and training. Cooperative agreements with other agencies may also affect equipment needs. The types of incidents could include industrial accidents, municipal emergencies, utility incidents, climbing or caving accidents, confined space rescues, car over-the-edge scenarios, farm machinery accidents, remote or wilderness rescues, water incidents, or snow and ice responses. Some equipment can be used across multiple environments, but unique situations may require specialized gear. Ultimately, the authority having jurisdiction, or AHJ, has final authority over what equipment is approved. A competent person should evaluate each item based on its suitability for the anticipated needs: rope diameter compatibility, hardware compatibility, NFPA 2500 compliance, minimum braking strength, system design, potential fall hazards, and the skill level of available personnel. Organizations should prioritize equipment that meets NFPA 2500, the 1983 edition. This standard sets baseline performance requirements for life safety rope and associated gear, and serves as a key reference for equipment selection. However, be cautious, manufacturer claims and NFPA requirements may not always match. Just because a manufacturer states that their product meets NFPA 2500 doesn't guarantee it unless it has been independently tested and marked. Understanding the difference between marketing claims and verified compliance is critical to safe rope rescue operations. Rope rescue components must work together seamlessly. Different equipment items are designed for specific rope diameters, applications, and environments. Using incompatible gear can compromise safety. Training is essential. Every rescuer must understand the capabilities and limitations of the equipment they use, including compatibility with other components. Finally, before any equipment is placed into service, it should be inspected by a competent person to ensure it meets organizational requirements and arrived undamaged. The AHJ must also confirm that personnel have received proper training with the equipment. Remember, the effectiveness of your rope rescue operation depends on how well your gear, training, and rope systems integrate. When selecting and using rope rescue equipment, it's not enough for the equipment to simply hold a person's weight. Every component must provide sufficient strength to perform reliably under the load it may encounter. But we don't stop there. Equipment must also provide a margin of safety above that load, a factor that accounts for real-world conditions, including rigging angles, friction, dynamic forces, or the unexpected movements of a patient or rescuer. Think of it this way: life safety equipment isn't just designed to barely work. It's designed to exceed expectations, so that even when conditions are less than ideal, the rescuer and the patient remain protected. This extra strength above the expected load is what allows us to operate safely in unpredictable environments. Before we dive into the NFPA 2500 classifications, it's important to understand what a kilonewton, or kN, actually represents in rope rescue. A kilonewton is a unit of force. 1 kilonewton equals roughly 225 pounds of force. So when we say a rope has a major axis strength of 40 kilonewtons, we're saying it can theoretically hold about 9,000 pounds along its strongest axis. That's far beyond the weight of a single rescuer or patient, which gives you an immediate sense of the safety margin built into life safety equipment. Now, NFPA 2500 classifies equipment into 3 categories based on strength and intended use. G for general use, most robust classification, intended for general rescue operations. Historically grounded in NFPA 198, the major axis strength requirement is 40 kilonewtons, or about 9,000 pounds. This ensures that even moderately trained rescuers are unlikely to overload the system. T for technical use. Introduced in the 1990s for highly skilled technicians, this equipment is allowed to have lower strength requirements than G-rated gear, but still significantly higher than personal escape gear. Major axis strength is 27 kilonewtons, roughly 6,000 pounds. E for escape use. Lower test requirements, intended only for emergency personal escape situations. Major axis strength is 15.5 kilonewtons, or about 3,500 pounds. This allows the gear to be lighter and more portable, ideal for carrying into hazardous environments. It's important to note that these classifications are minimum standards. Many products exceed these numbers, and understanding the actual rated strength in kilonewtons allows rescuers to plan and analyze their systems more effectively. When discussing rope rescue, it's critical to understand load ratios and how strength relates to the forces in your system. Every piece of rope rescue equipment has a rated strength, often listed in kilonewtons. For example, a 27 kilonewtons carabiner can theoretically hold about 6,000 pounds. That's a lot more than the weight of a rescuer and a patient combined. Load ratio is the comparison between the force applied to the system and the strength of the equipment. Knowing the actual kilonewtons rating is more useful than just the G, T, or E classification because you can calculate if your system has enough safety margin. For instance, if a rescuer weighing 200 pounds is connected to a rope system during a hoist, the static load is far less than the 9,000 pound strength of a G-rated rope, giving you a huge safety margin. However, dynamic loads like a fall or swing can multiply forces several times. That's why understanding load ratios in KN is essential. It helps you predict whether your gear can withstand sudden spikes in force. T-rated equipment is intended for technical systems where trained rescuers manage forces carefully. Even though it's rated lower than G, it's still strong enough for most field operations if used properly. Lab test results are controlled, but real life introduces angles, friction, and other variables. Always plan for these additional forces. The minimum braking strength, or MBS, is the force at which a piece of equipment actually fails during testing. For ropes, this is often measured along the major axis in kilonewtons. For example, a 40 kilonewtons rope fails at around 9,000 pounds. MBS is derived from the design load, which is the maximum load the manufacturer expects the equipment to handle safely during normal use. Why is this important? It gives rescuers a baseline for calculating safety. If you know your rope has a 40 kilonewtons MBS, and your system's maximum anticipated load is 600 pounds, you can calculate the system safety factor, SSF. The SSF tells you how many times stronger your equipment is than the load it must carry, factoring in rigging angles, friction, and dynamic effects. Quick analogy, if a 40 kilonewtons rope is a bridge rated for 9,000 pounds, and your rescuer plus patient is 600 pounds, that bridge could theoretically hold 15 times that load. That's your baseline safety margin. Each piece of gear also has a component safety factor, which compares the MBS of that component to the actual load applied. For example, rope rated at 9,000 pounds, 40 kilonewtons. Rescue system mass, 600 pounds, 272 kilograms. Component safety factor, 9,000 divided by 600 is equal to 15 to 1. This ratio shows how much stronger the rope is than the expected load, but remember, this is just one component. Every piece of equipment contributes to the overall system safety. Carabiners, pulleys, webbing, and anchors may all have different ratings, and their interaction affects the total safety factor. Important, don't assume a high component safety factor alone guarantees system safety. You must analyze the entire system in context of real-world forces. The authority having jurisdiction, AHJ, is ultimately responsible for determining the appropriate safety factor for their team. This decision is based on hazards, risk, training, and system complexity. The AHJ should focus on the system safety factor, SSF, rather than individual component ratings. SSF compares the weakest link in the system to the anticipated load. Example, if your system has a rope rated 40 kilonewtons, a carabiner rated 25 kilonewtons, and webbing rated 15 kilonewtons, the SSF is limited by the 15 kilonewtons webbing, not the rope. Both static loads, normal weight, and dynamic loads, falls, swings, or sudden tension, should be considered. MBS, load ratios, component safety factors, and classifications like G, T, and E are all tools. The most important factor is a trained rescuer who can understand system forces, select appropriate gear, and build a safe rescue system. Carabiners are self-closing connectors that link different elements of a high-angle or technical rescue system. Think of them as the critical bridges that hold your system together. Their strength and reliability are non-negotiable because every connection in the system depends on them. Carabiners are rated either G for general use or T for technical use. G-rated carabiners are tested to 40 kilonewtons. These are designed for general rescue use and provide a high margin of safety even for less experienced rescuers. T-rated carabiners are tested to 22 kilonewtons. They are lighter and smaller, meant for highly trained technicians who understand system forces and can maintain safety even with slightly lower strength. Most carabiners are made from aluminum alloy or steel. Aluminum, lightweight, less expensive, resistant to rust. However, aluminum can wear faster under severe shock loads, and some designs are not as strong as steel equivalents. Steel, heavier, stronger, more durable under high loads. Requires more maintenance to prevent rust unless stainless or plated. Steel carabiners often hold up better under repeated or severe shock loading. Locking mechanisms. Manual locking requires the user to screw or twist the gate closed. Extremely secure if properly engaged, but it depends entirely on the rescuer to remember to lock it. Autolocking, self-locking the gate locks automatically when closed, reducing the chance of human error. Some designs require an additional twist or slide motion, but overall, they offer higher confidence in system security. Why non-locking carabiners are dangerous? Non-locking carabiners rely only on the spring tension of the gate. During use, rope movement or contact with other gear can force the gate open. In a rescue system, even a brief gate opening can cause catastrophic failure. Non-locking carabiners are never acceptable for life safety or technical rescue systems. They may be used for low-risk tasks, such as attaching gear to a harness, but they should never support personnel or load-bearing components. Always select the correct strength rating G or T for the operation. Choose a locking mechanism appropriate to the situation, manual or auto-locking. Never use non-locking carabiners in life safety systems. Remember, your carabiner is only as reliable as the knowledge and habits of the rescuer using it. Choosing the right type, material, and locking mechanism is a critical decision for system safety. Alright, let's break down the parts of a carabiner. Knowing these is essential for safe rescue operations. Basic parts. Frame. This is the backbone, the main body that carries the load. Think of it like the spine of the carabiner. Gate. The part that opens to let you clip ropes, slings, or other gear. Hinge to the frame, it may include a locking mechanism. Latch keeps the gate closed. Some are smooth for easy clipping, others are notched for extra security. Critical points. Strongest point, the spine, the long axis, is where the carabiner can handle its maximum rated strength. Always orient loads along the spine. Open gate danger. Even a partially open gate can reduce strength by 20 to 30% or more. That's a huge safety risk. Keep gates closed and locked whenever possible. Shapes matter. D. Shifts load to the spine for maximum strength. This is your go-to for heavy anchors. Modified D. Larger gate for easier clipping. Slightly less strength than D. Pair/HMS. Big gate opening for rope handling and munter hitches. Slightly weaker than D but very versatile. Think of carabiner shapes like bridges. Some carry massive loads straight across D. Others are flexible for specialized traffic but can't take quite as much weight. Pair/HMS. Now let's talk about how to choose and use carabiners in real rescue systems. Classifications. G. General use heavy duty, high strength, rated 40 knots. Safe for all rescuers in standard situations. T. Technical use lighter, compact, rated 22 knots. Good for trained rescuers who understand system forces and proper usage. Material considerations. Aluminum, lightweight, portable, corrosion-resistant. Great for hauling and rope systems, but less forgiving under repeated shock or misuse. Steel, stronger, more durable under high stress, excellent for anchor points. Heavier, and may require rust prevention. Component integrity. Always check the gate and locking mechanism. Any wear or damage reduces strength. Align the load along the spine. Side loading is dangerous. Remember dynamic forces. Falls, jerks, or sudden shock loads can exceed static strength. Choose carabiners rated well above the expected load. Shape considerations. D and modified D. Optimized for spine loading. Common in anchors, pulleys, and main lines. Pair/HMs. Large gate for belays, munter hitches, rope handling. Trade-off is slightly reduced strength. Oval, symmetrical, versatile for multiple attachments. Slightly weaker than D but easy to manage slings and pulleys. Always match the carabiner to the task. Strength, weight, material, and gate type matter. Pay attention to orientation, locking, and load direction, because even the strongest carabiner can fail if misused. With training and experience, you'll select the right carabiner every time, keeping your system and your team safe.
Now, let's dive a little deeper into carabiner strength. We already know a carabiner is strongest along the long axis, with the gate fully locked. That's the spine, the part designed to carry the full load. But what happens when things aren't perfect? First, if the gate isn't locked, strength drops significantly. If the gate is open, it drops even more. Side loading, where a force pushes on the gate instead of the spine, is the weakest configuration and one of the most common mistakes we see in the field. Now, there's another tricky one: tri-loading. That's when three pieces of rope or hardware converge on the same carabiner, often from different angles. It creates multiple vectors of force at once, which can push the carabiner in directions it wasn't designed to handle. Even if the carabiner is locked, tri-loading can drastically reduce strength. The spine might not be aligned with the main load, and the gate can experience bending forces. That's why we train to avoid tri-loading. If you absolutely have to, use a larger carabiner, consider a dedicated anchor carabiner, or add a pulley or ring to redirect the load safely. Size matters too. A bigger carabiner makes it easier to properly orient ropes and gear. If ropes are pressed against the gate or crowded in, you're compromising strength, no matter the rating. Check the markings on your carabiner. A T means technical use, rated 22 kilonewtons along the spine, for trained users. AG is general use, rated 40 kilonewtons, more forgiving for typical rescue loads. Older carabiners might have an L, which is essentially the old T rating. And while carabiners to other standards might sometimes be approved, that's always up to your AHJ, and only after a competent person evaluates them. Bottom line: keep the load on the spine, avoid gate loading, don't tri-load, and always respect the ratings. The carabiner is your link to safety. Treat it like it can't fail, because in rescue, small mistakes become big problems fast. Now that we've talked about carabiner shapes and strength, let's look at how those strength ratings actually come to be. Not all carabiners are created equal, and not every carabiner you see in the field has been tested or labeled. NFPA 2500, 1983, requires something called the 3 sigma method for calculating minimum breaking strength, or MBS. Here's how it works. Manufacturers test a minimum of 5 samples of the same carabiner. They calculate the average breaking strength, then subtract 3 times the standard deviation. The resulting number, the 3 sigma MBS, is what they are required to advertise. Essentially, it gives us a statistically significant number that accounts for variability in production. Now, not all carabiners are labeled or tested. Some have no markings at all. If you can't see a rating stamped on the carabiner, or a reference to a standard like NFPA or ANSI, you simply cannot be certain of its open gate strength, minor axis or major axis strength, or overall reliability. In those cases, always check the referenced standard to understand what the rating, or lack thereof, really means. You might also run into carabiners marked to ANSI Z359.12, especially in industrial or co-worker-assisted rescue environments. The key difference is how these carabiners handle gate loading. Always know the standard your gear was tested to, because the numbers can vary significantly. Finally, material and design matter. Even carabiners with similar specifications can balance weight, size, and strength differently. For heavy-duty rescue, solid aluminum or steel carabiners are usually a better choice than lightweight hollow aluminum models. As always, the authority having jurisdiction, or AHJ, should decide which carabiner types are appropriate for the intended operations. Bottom line, pay attention to markings, know the testing standard, and select carabiners that meet both the strength and durability needs of your rescue system. When selecting carabiners for rescue systems, one detail that often gets overlooked is the gate opening. This is the actual space that opens when you push or twist the gate, and it can make a big difference in how your carabiner handles different loads and gear. A carabiner with a large gate opening allows you to clip in bigger ropes, multiple slings, or bulky hardware without fighting to get everything seated properly. It's essential when you're dealing with complex rigging or situations where speed matters. On the other hand, a smaller gate opening can actually be an advantage in certain cases. It helps prevent overstuffing the carabiner, which can compromise the proper placement of ropes and hardware and potentially reduce its strength along the spine. The key takeaway here is simple. Match the carabiner's gate size to the task at hand. Know the dimensions of the ropes, webbing, or gear you'll be using, and choose a carabiner that can handle it comfortably without forcing it. A well-matched gate opening keeps your system safe, efficient, and easy to manage under load. The primary job of a carabiner in a rope rescue system is simple, but critical. It has to maintain a secure link between all elements of the system. That means the gate must stay closed at all times. If it doesn't, ropes, slings, or hardware can come unlinked, and the system can fail, sometimes catastrophically. Carabiner gates can open accidentally in a few common ways. They might get pressed against a wall or rock, forcing the gate to pop open. A rope or piece of webbing can also slide across the gate and push it open. These are not just theoretical scenarios. Anyone who's been on a technical rescue knows how easily things can shift under load. This is why locking carabiners are essential. They provide a safeguard against accidental gate openings, keeping your system intact even when things move or bump unexpectedly. Locking carabiners generally fall into two categories: manual locking and auto-locking. Manual locking carabiners, sometimes called screw locks, feature a sleeve that you physically twist or screw over the gate or nose to secure it. It's very reliable when done correctly, but it relies entirely on the user remembering to lock it. Auto-locking carabiners take some of the human error out of the equation. Their spring-loaded sleeve snaps into place automatically when the carabiner closes. Some designs even require an additional action, like twisting or sliding, to unlock, adding an extra layer of safety. Regardless of the type, it's the rescuer's responsibility to ensure gates stay closed during use. Carabiners that jam, fail to lock, or show wear should be retired immediately. If you ever encounter a jammed screw-lock carabiner, there's a methodical way to handle it safely. Attach it to a harness or anchor, reload the carabiner under tension, and attempt to loosen the sleeve gradually. Short pieces of webbing or, as a last resort, pliers can give you leverage. After such an incident, the carabiner should be considered retired, even if it appears undamaged. In rescue systems, attention to detail with locking mechanisms isn't optional. It's a matter of safety. Every locked gate is a small insurance policy against system failure. When it comes to carabiners, it's simple. Use them only as the manufacturer intends. Every carabiner is designed with a particular function in mind, and the safe use of that piece of hardware depends on following those specifications. Typically, carabiners are meant to be loaded along their major axis. That's the long axis, running lengthwise along the spine. That's where they achieve their maximum strength. Problems arise when a carabiner is side-loaded, meaning forces push across the gate rather than down the spine. The gate is the weakest part, so side-loading puts unnatural stress on the carabiner and significantly reduces its strength. Side-loading can sneak in when a carabiner is rigged so it cannot rotate naturally with the forces applied to it. This twisting, especially when the carabiner is hard-linked to multiple points, can cause catastrophic failure. Let's talk about hard links first. Hard linking happens when a carabiner is attached directly to a rigid anchor, like an eye bolt in a wall, a second carabiner that doesn't rotate, or even a vehicle tow hook. These setups can prevent the carabiner from aligning with the direction of force, creating those dangerous side loads we just talked about. One solution is the soft link. Think of it as a flexible buffer, a short piece of rope, webbing, or cordage placed between two hard points. A soft link allows the system to adjust to force direction and reduce twisting stress on the carabiner. When using soft links, make sure you understand the performance specifications for the configuration you intend. Whether you loop it, girth hitch it, or use it end-to-end. Swivels can also help mitigate twisting, but they're not a cure-all. Some loading conditions can still compromise the setup. The key takeaway here is that hard links without flexibility are a recipe for sideloading, and sideloading is where strength gets compromised. All high-angle rescue equipment, including carabiners, is designed for a specific manner of function. Use it any other way, and you're introducing the potential for equipment failure. Misuse isn't just theoretical. It can result in severe injury or death. A carabiner loaded sideways, or a gate accidentally forced open under load can all lead to catastrophic consequences. Respect the design of every piece of equipment. Keep loads along the spine, avoid sideloading, and ensure flexible connections where needed. When in doubt, think of the carabiner as a guardian of your system. Treat it carefully, and it will protect you in turn. Carabiners are more than just hardware. They are critical links in the life safety chain. That means you can only rely on them if they're in good condition. Before each use, always inspect your carabiners carefully. Look for any signs of damage or wear. Cracks, sharp edges, corrosion, burrs, deep gouges or dents. Even small imperfections can compromise strength. Check the gate function. Does it open and close smoothly? Look for frame deformation, damaged hinge pins, dented latches, or any evidence of heavy loading. The locking mechanism should operate effortlessly, whether it's a screw lock or autolock. If it sticks or jams, it's time to retire the carabiner. Clean carabiners work best. Light dust and dirt can usually be brushed or blown off. For stickier buildup, wash in warm, soapy water or a citrus-based cleaner. This is especially important after exposure to salt water, salt air, or other corrosive environments. After cleaning, dry thoroughly and lubricate with a dry lubricant. Graphite or wax-based is ideal, focusing on the hinge pins, springs, latches, and locking knobs. Wipe off any excess before storing. Remember, a clean, well-maintained carabiner isn't just easier to use. It's a carabiner you can trust when it matters most. Screw links, sometimes triangular, sometimes semicircular, are another type of connector you'll see in rope systems. They're especially useful when you need a smaller, compact connection point. Unlike a carabiner, a screw link relies entirely on its manually threaded sleeve to stay closed. That means you need to turn the sleeve fully to secure the opening. For maximum safety, it's best to tighten screw links with a wrench, ensuring they cannot accidentally work themselves open during use. Because of this, screw links should ideally be integrally connected, meaning they're screwed into place and left there for the duration of a job, rather than opened and closed repeatedly. This makes them less convenient for quick rigging changes but far safer when used correctly. It's important to understand that NFPA 2500/1983 doesn't address screw links, so you won't find an NFPA-certified MBS for these connectors. Not all screw links are intended for life safety. Only those explicitly tested and marked to the European EN 362 standard should be used in rescue applications. Hardware store screw links, while cheap, are not rated for life safety. Screw links are strongest along their primary axis with the sleeve fully locked and tightened with a wrench. Loading them sideways or on a minor axis can dramatically reduce strength. EN 362 requires 25 kilonewtons along the major axis, gate closed and locked, and only 10 kilonewtons along the minor axis. The idea that a screw link is equally strong on the short axis is a myth. Unlike carabiners, screw links are not self-closing and are not tested with the gate open, so their integrity depends entirely on proper closure. Many screw links used in lifting applications are marked with a working load limit, WLL, usually 1/5 of the rated braking strength. This is different from NFPA's approach, which uses statistical testing to establish a minimum braking strength. Screw links aren't inherently unsafe, they're just more sensitive to human error. They shine in applications where compact size and short system length are important, such as with foot loops in ascending systems. But because the sleeve must be fully tightened, preferably with a wrench, before loading, they work best when mounted in a way that prevents accidental opening. Alright, let's talk about braking devices and descenders. These are essential tools we use to manage the rate at which a load is lowered or a rescuer descends in a rope system. Simply put, they help us control movement safely. Most of these devices rely on friction to work. That means as the rope moves through the device, heat is generated. Heavier loads, faster descents, or prolonged use can increase that heat. If we aren't careful, this heat can damage the rope or equipment, or even cause second-degree burns if we touch it with bare skin. So, how do we prevent that? First, select a descender that's designed to dissipate heat. Second, avoid running rope through the device too quickly. And finally, always pay attention while using the device. Don't assume it's safe just because it looks normal. Now let's go over the different ways we use braking devices. A true braking device is usually stationary and anchored. It holds the load in place or lowers it in a controlled manner. A descender, on the other hand, moves along the rope, like when we rappel a rescuer or a litter. Choosing the right device isn't just about what you have on the truck. You need to consider rope diameter and compatibility, the weight of the load, the type of rescue, and how trained the team is with that device. Remember, one device isn't perfect for every situation. Rope characteristics also affect performance. Smaller diameter ropes run faster than larger ones. Polyester ropes run faster than nylon, and dry-treated ropes run faster than untreated ropes. Hard or stiff ropes move faster than softer ones. And of course, the more weight below the device, the faster the rope moves through it. For rope care and smooth operation, linear rope passage is ideal. That means the rope runs straight through the device without wrapping or twisting. And always match the device to the task. For example, a heavy rescue litter device might not be the best choice for a single-person emergency escape. It's overkill and harder to control. The key takeaway here: understanding your device, knowing the rope characteristics, and matching them to the task keeps the system safe and efficient. Now we're moving into the difference between autolocking and manual devices. Understanding these is critical, because both types are commonly used in the field, and each has its own strengths and weaknesses. Let's start with autolocking devices. These are designed to automatically stop the rope if the operator lets go. That means they provide an extra layer of security, especially in high-risk scenarios. However, to move the rope through the device, the operator usually has to engage an override. This allows controlled movement while still keeping the safety feature active. Remember, completely letting go isn't considered normal operation, but many rescuers develop habits that rely on this automatic stop. Autolocking devices are powerful, but they require proper training and experience. You need to know exactly how they work and how to override them when necessary, so you can maintain control of the system under all conditions. Let's talk about manual devices. These are simpler by design and require the operator to maintain an active grip on the rope to control braking. If you let go, the rope will run freely unless a secondary safety system is in place. Many experienced rescuers actually prefer manual devices for certain tasks. They have fewer moving parts, tend to be less sensitive to rope diameter, and are easier to maintain. But because they don't automatically stop, they demand constant attention and proper technique. Like auto-locking devices, manual devices also require training and experience. Understanding the friction, handling characteristics, and safe operation is critical to avoid accidents. When selecting a braking device, auto-locking or manual, consider these key specifications. Do you need auto-locking or panic lock features? Can the friction be adjusted for your application? Size and weight for portability and efficiency. Compatibility with your life safety rope, escape rope, or webbing. Material of construction and durability. Ability to dissipate heat during prolonged or heavy load use. Level of training required for your team to operate safely and effectively. Choosing the right device isn't just about preference. It's about the task, the rope, and the team's experience. Proper selection combined with training keeps your system safe and reliable in the field. When selecting a braking device, there are several additional considerations beyond just whether it's manual or auto-locking. One key factor is variable friction. This becomes especially important during lowering or descending operations where the load might change, or when the rope weight below a person varies, like on a long rappel. Devices with variable friction go beyond simple stop-and-go functionality. They allow you to wrap, clip, or add friction components as needed to safely manage the descent. Performance specifications also need to be balanced with the size, shape, and weight of the device. For example, if you're working next to a roadway, a truck-mounted capstan might be ideal for lowering and raising operations. But if rescuers have to carry equipment into the field, the size and weight of the device become much more critical. Compatibility with other equipment is another important consideration. Some braking devices work with a wide range of ropes and webbing, while others are highly specific to certain materials, constructions, or diameters. Most organizations rotate their ropes and soft goods more often than their hard goods, so having a descender that functions with a variety of ropes is usually safer. Even though some devices may be rope-specific, the best ones aren't overly restrictive. They function well across a narrow range of rope diameters without issues. Markings and rope condition also affect device performance. Even ropes of the same make and model can perform differently depending on age and wear, so it's important to train on the types of ropes actually used in operations. Finally, the material of the descender has a big impact on performance. Steel is durable and smooth but heavier to carry into the field, while aluminum is lighter but more susceptible to wear. Rescuers should be trained to inspect rope paths carefully for wear and retire any descenders that show excessive damage or wear. By keeping these factors in mind, we can make informed choices about braking devices and ensure safe, efficient operation in the field. Friction is the main mechanism by which most braking devices operate. But friction comes with a natural side effect: heat. The heavier the load you're lowering, the more friction is generated, and the longer the descent, the more heat builds up in the device. A braking device that gets very hot can create serious hazards. It can burn a rescuer's skin, damage ropes and other soft goods, and even reduce the strength of the device itself. That's why it's critical to consider both the anticipated weight of loads and the typical distances they will be lowered when selecting a braking device. Heat dissipation plays a big role in how safely a device can be used. Devices with a larger surface area or an open design will shed heat more effectively. By keeping friction and heat in mind, rescuers can operate braking devices safely and protect both themselves and their equipment from damage. When selecting a braking device or descender, the first thing to consider is the rope. The device must be properly sized for the diameter of rope you're going to use. If it's too big or too small, it won't give you the control you need. Next, think about friction. A good descender should provide enough friction so you can control your descent precisely, without having to use brute strength. You should be able to move as slowly as you need, and stop completely at any time. Keep in mind that hardware, gear, and gloves add to your effective weight. You're not just carrying your body weight. These extra pounds increase the load on the braking device. In rescue scenarios, the load may be 1 or even 2 people in a litter or harness, which dramatically increases the weight and changes how the device handles. This is why understanding friction and control is critical before you start lowering a rescue load. It's also essential that you can lock off the device before starting a descent. This allows you to secure yourself on the rope and stay stopped without having to hold onto the device constantly, which is particularly important when managing a rescue load. The device must be strong enough to provide a proper safety factor for the intended use, and it has to be long enough to handle the distance you'll be lowering or descending. Finally, make sure the device is designed for the type of rescue work you'll be doing. Lowering a heavy rescue load is very different from performing a personal rappel, so choose a descender that matches the application and anticipated load. When selecting braking devices, response organizations need to consider the specific purposes for which the devices will be used. Think about the performance you need, how often the device will be used, and the level of training your team has. At a minimum, any braking device, whether it's used for lowering a load or personal descent, should give you solid control over the speed of the descent. It should brake smoothly without bouncing or creating shock loads, and it shouldn't damage the rope by plucking, stripping, or abrading the sheath. Finally, it must stay securely on the rope and not detach accidentally. Many organizations carry a range of devices to cover different tasks. You might have one device for lowering a litter, another for personal escape, and a third for technical rope operations. When it's time to use the equipment in the field, Rescuers need to know which device fits the specific situation. Consider the weight of the load, the length of the descent, environmental factors, what rope you have available, and any auxiliary equipment you're using. NFPA also classifies descenders, similar to other rope rescue equipment, into 3 categories: G for general use, T for technical operations, and E for escape. The main difference between these classifications is the intended load and purpose. In addition to certain ISO test methods, NFPA requires deformation testing to ensure the devices can handle real-world forces. For example, a G-rated device must withstand at least 11 knots, a T-rated device at least 5 knots, and an E-rated device is subjected to a dynamic test to simulate an escape scenario. Understanding these classifications helps ensure your team selects the right device for the mission, balancing safety, control, and operational effectiveness.
When it comes to selecting a braking device, there are a number of factors you need to keep in mind. First, there are auto-locking devices which have grown in popularity due to their fail-safe advantages. These devices can give rescuers a lot of peace of mind, but there are some trade-offs. While they are excellent for safety, they tend to be less versatile and are often limited to a very narrow range of rope diameters. Using the wrong diameter rope with an auto-locking device can create hazards, including insufficient friction, jamming, or even accidental disengagement. Auto-locking devices generally work by wrapping the rope around a moving bollard or block of metal. Tension on the rope compresses it against the block, stopping progress automatically. Many of these devices also act as progress-capturing pulleys for raising operations. They typically require a two-handed operation. One hand operates the handle, while the other manages friction on the tail of the rope. Remember that auto-locking devices combine braking and safety features, but you must always match them to the correct rope and load. Next, let's look at a couple of versatile options. The climbing technology Sparrow is a self-braking descender designed for both descent and ascent. It features an external brake spur that allows you to quickly add friction, and the automatic returning brake lever helps maintain speed control. It's designed for use with an 11 mm rope. The CMC MPD, on the other hand, combines a bollard with a pulley, making it a dual-purpose device. Switching between lowering and raising is seamless and doesn't require changing hardware. It comes in 2 models for 11 mm and 12.5 mm ropes, so you can choose the right fit for your system. Both of these devices are designed to balance ease of use with reliability, making them solid choices for field operations. The Harken clutch is an auto-locking device with some unique features. It has a stainless steel rotating sheave that makes an audible click when tension is applied, an auto-locking function, a panic lock, and even a force-limiting feature to prevent overload. There's a becket for attaching a carabiner, so it can be integrated into a haul system without removing it from its anchor. This device is designed 11 mm clutch for 10.5 to 11 mm ropes, and the 13 mm clutch for 12.5 to 13 mm ropes. The ISC D4 and D5 are work rescue descenders with offset bollards, auto-locking, and anti-panic features. They're rated for heavier loads and are designed to slip between 4 and 6 kN, allowing them to double as fall arrest or belay devices. One of the great features is that they can be rigged to a rope without removing them from the anchor, and the release mechanism is easy to operate even with gloves on.
The CMC clutch by Harken Industrial is the latest evolution in rescue and rope access hardware. The clutch is patented and made in the USA by CMC and Harken Industrial in a partnership that combines over 90 years of experience in rescue and rope management. Suited to a multitude of rigging operations, the clutch moves seamlessly between anchor-based systems and personal use. It offers unparalleled versatility for the rope technician through efficient hauling, controlled lowering, easy ascending, smooth descending, belaying, and twin tensioning. The heart of the clutch is a stainless steel ratcheting and rotating sheave. The sheave has 3 key benefits. First, it delivers highly efficient progress capture for easy hauling and ascending, making the clutch more efficient than a traditional cam-style descender. Second, the clicking sound provides an audible safety check that confirms the rope is feeding properly and progress is being made. Third, the rope takes an intuitive path around the sheave, making the clutch easy to read. A double latch side plate creates a two-step opening process. This safety feature prevents the side plate from opening unintentionally. The independent attachment point allows the clutch to be loaded and unloaded without unclipping it from the carabiner. The user is able to perform quick transitions with less risk of dropping the device. The clutch has an ergonomic control handle that is comfortable and easy to use with light and heavy loads. The clutch also has a built-in force-limiting feature that allows it to safely and reliably slip in overload situations. When arresting a fall, the clutch limits the dynamic impact load to dissipate energy. Another strength of the clutch is its all-metal components. The machined aluminum chassis and stainless steel wear guards deliver lightweight durability that lasts longer than plastic parts. The versatility of the clutch is further increased with the integrated becket, which allows direct connection of pulleys for building mechanical advantage systems. The compactness of the clutch and orientation of the handle also makes it ideal for twin-tensioned rope systems. When two clutch devices are brought together in the double clutch TTRS, users can maintain nearly equal tension on both lines so that the load is shared across two rope systems. The gray clutch is designed for rope diameters of 10.5 to 11 millimeters and is certified to NFPA general use, ANSI, and EN standards. The red clutch is designed for rope diameters of 12.5 to 13 millimeters and is certified to NFPA general use and ANSI. Both models are rated to a maximum load of 272 kilograms, or 600 pounds, with a 40 kilonewton pulley and a 22 kilonewton integrated becket. The clutch simplifies training and operation because it has the functionality and safety features of multiple devices in one. The thoughtful design and materials create a compact device that can accompany users into remote settings and extreme environments.
The Petzl ID is a classic professional-grade self-braking descender. It comes with multiple handle positions for normal descent, panic stops, and storage. Two versions exist, one for 10 to 11.5 millimeters ropes supporting up to 200 kilogram, and another for 11.5 to 13 millimeters ropes supporting up to 272 kilogram. One limitation is that it has a narrow, sweet spot, so it may not perform as well with lighter loads or shallow slopes.
Self-braking descenders consists of two products. The IDS is for difficult access and emergency rescue kits. It is primarily used with 10.5 to 11 millimeter diameter ropes and for heavy loads up to 200 kilograms. The IDL is intended for technical rescues. It is primarily used with 12.5 millimeter ropes and for heavy loads up to 272 kilograms. Both are designed to allow the user to control their descent and to stay in position without having to tie off the device. The handle provides easy access to all of the descender's functions. Its ergonomic shape is comfortable to use. The IDS and IDL both offer multiple options to the user. To control speed when descending, to stay in position by locking the handle without having to tie off the device. To move smoothly up and down an incline or horizontally by pressing on the button. To make short ascents up the rope. To make a reversible haul system, for example, with an IDS as part of a rescue kit. To pick off, lower, and evacuate a team member. With an IDL in a rescue system with a backup belay, in order to raise and evacuate the victim. And to belay a leader using climbing technique. In addition, the handle has a compact carrying position in order to prevent it from catching on an object inadvertently. To limit the risk of an accident due to user error, ID descenders are equipped with additional functionalities. If the user loses control during the descent, the natural reflex may lead them to pull hard on the handle. or an object or the user might cause the handle to inadvertently snag. In both cases, the integrated anti-panic function automatically activates to brake and then stop the descent. If the rope is installed backwards in the device, a clamp locks down, immobilizing the user. The line of ID descenders consists of two models. The IDS is intended for difficult access and rescue kits. The safety gate prevents dropping the device, simplifies passing intermediate anchors, and makes it easy to install and remove the device at any point on the rope. The IDL is designed for technical rescues. Its rugged construction and compatibility with large diameter ropes makes it particularly well suited to hauling and lowering heavy loads. Whichever ID descender you choose to employ, you will undoubtedly appreciate the multiple functionalities and ease of use, two fantastic benefits when in the field.
The Petzl Maestro is highly efficient for raising operations thanks to its large fixed-direction sheave. It locks off automatically under load, and the handle allows controlled rope release. It does not have a panic lock, so operators need to use caution, especially less experienced rescuers. Available versions accommodate ropes from 10.5 mm up to 13 mm, supporting loads up to 280 kg.
I'm Steve Petty with the Davis County Sheriff's Search and Rescue Team. I'm a 17-year member of Search and Rescue, and we do rescue operations in the Wasatch Mountains of Utah. The Maestro represents a big step forward in technology for creating a device that makes haul systems more efficient and intuitive to operate. Whether I'm working as a litter attendant, operating a belay, or directing the entire rescue operation, I know I can trust the Maestro as a key component of our rescue systems.
Ça fonctionne.
Finally, let's look at a few more devices. The Skylatech lorry is designed for professional rescue and work positioning. It automatically blocks in the event of a fall and combines auto-lock and panic stop features with a descent handle for maximum control. The Skylatech series is ultra-compact, ergonomic, and highly durable. It prevents rope twisting and kinking, has an auto-returning lever for efficiency, and can be rigged remotely or integrated into a haul system. The SMC Spider can be used for lowering, descent, and positioning. It can be installed or removed from the anchor without unhooking the system, is auto-locking in a hands-free mode, and has a wide sweet spot, making it versatile for a range of rescue applications. Okay team, before we start running these auto-locking devices, let's talk about some precautionary notes. These are the real-world things that can make a big difference when you're out on a call or training. First, always make sure you're using the correct rope diameter. These devices are very particular, and most of them only work well with a narrow range. Using the wrong diameter can change how the device behaves. It might slip or not lock as expected. Next, think about the rope itself. Not all ropes are created equal. Differences in how they're made, like the hardness, the hand, or even slight variations in diameter, can change the way the device performs. So if your department decides to switch ropes or devices, it's not something you want to just wing it. Test it first and give your team some time to get used to the change. Environmental conditions. Now, let's talk about the conditions. Wet, icy, or muddy ropes will behave differently than dry ropes. This is especially true for auto-locking devices. The friction changes, the feel changes, and that can affect how smoothly or safely you descend. If these are conditions you expect to encounter, practice with them, so you're ready when it counts. Also, keep an eye out for debris in the device shell. A little dirt or grit can really mess things up. Heavy loads and long descents. Finally, pay attention to the load and the length of the descent. Heavy loads, long lowers, or extended descents can challenge auto-locking devices. Because they have a limited rope path and smaller mass, they don't dissipate heat as efficiently as a big brake rack. That means they can jam or overheat if you push them too hard. Always anticipate this and plan accordingly. So, the key takeaway here is, know your rope, know your device, know the conditions, and respect the load. If you do that, these tools will work as designed and keep you safe. Alright, let's switch gears and talk about non-autolocking braking devices. These are for trained and experienced users only, definitely not a beginner tool. The pros? They're very versatile, you can use them with a wider range of rope diameters, and the friction is adjustable. This makes them great for longer descents or situations where you need fine control. The cons? Well, they don't autolock, which means you have to actively control the rope at all times. That's why only experienced users should touch these devices. They demand attention and skill. One neat thing is that you can retrofit a non-autolocking device to work like an autolocking one by using a self-jamming friction hitch, like an autoblock. It's not automatic, but it adds an extra layer of safety in the right hands. Next up, brake bar racks. These are particularly good when you need to adjust friction over a wide range, even under load. They're a favorite for long rappels or lowering heavy loads. Pros: great control, friction is easy to adjust, perfect for long lowers, and can handle heavy loads. Cons: they don't autolock, so they're free running again, you need a skilled operator. The brake bar rack has two main components. Frame, usually stainless steel, sometimes titanium if you want lightweight. Bars, these slide through the frame and control friction. Bigger bars equal more friction, smaller bars less. Simple but effective. There are two common configurations, J-rack and U-rack. The J-rack has one leg longer than the other. When rappelling, the open side should face the ground. Some racks even twist the eye 90 degrees so you can clip it properly to a D-ring on a harness. The U-rack has equal legs. The rope is woven through the bars, and a carabiner clips across the bottom bend. Friction is controlled by pressure with your brake hand, bar spacing, and the number of bars loaded onto the rope. Longer frames let you adjust friction more precisely, great for long drops. When using a brake bar rack, the bars are the only wear items. They need to be replaced periodically, and bars come in different sizes depending on how much friction you need. For a J-rack, the top bar is usually 1 inch in diameter and sometimes grooved to keep the rope centered. For a U-rack, the second bar down is often grooved, and most racks fill the rest with 5 aluminum bars, each about 7/8 inch. Some racks even have tie-off bars for extra friction or rope tie-off points. So, the key with non-autolocking devices and brake bar racks is, know your configuration, manage your friction, and maintain your gear. Used properly, these devices give excellent control and versatility, but you need skill and attention to get it right. Now, let's talk about the Scarab. Think of it as a miniature bar-type device. It's much smaller than a traditional brake rack, but it gives you similar performance characteristics in a compact package. What's nice about the Scarab? First, it doesn't twist the rope, which is always a plus. You can vary the friction so you still have control. It works with a wide range of rope diameters, roughly 9 to 13 millimeters. You can set it up in either single rope or dual rope configurations. And despite its small size, it's very strong. Of course, nothing's perfect. It has limited friction, so it can't cover the same wide range as a full-size rack. It doesn't dissipate heat as well, so heavy, long lowers might be an issue. And it's not autolocking, no panic lock features, so you still need the trained operator in control at all times. Finally, keep an eye on wear. Check both the frame and the crossbar regularly. The Scarab should be retired if the crossbar wears more than 0.030 inches or the frame wears more than 0.090 inches. This ensures your team stays safe and the device performs as intended. Next, let's cover the Figure 8 descender. You've probably seen these in movies or climbing videos. They're shaped just like the number 8, though with rings of unequal size. The smaller ring clips into your seat harness or anchor using a carabiner or screw link. The rope runs through the larger ring, creating friction that you control with your brake hand. They're made of steel or anodized aluminum, so they're durable. Figure 8s are free-running devices, meaning you control the speed of descent by gripping the rope. You can use any type or diameter of rope, even doubled ropes, and they dissipate heat very well. The open shape is versatile, giving you multiple rigging options. Of course, nothing's perfect. They don't auto-lock, so there's no panic lock feature. The rope can tangle easily. Friction is limited, so not ideal for heavy loads. They can be tricky to feed rope through while belaying. They've largely become obsolete, even in recreational climbing. Some figure 8s come with extra features. Sizes range from tiny escape 8s to larger styles. Some have protruding ears. These are called rescue 8s. These ears help the rope contour better, reduce accidental girth hitches, handle larger ropes, and dissipate heat more efficiently. It's easy to rig and provides moderate friction. It does twist the rope, and you may need to disconnect to de-rig. A higher friction rig gives more control for heavier loads, but you need to avoid unlocking the carabiner under load. Finally, the wraps you choose depend on your skill level, the weight of the load, environmental conditions, and the dimensions of the device itself. So, the figure 8 is compact, versatile, and heat efficient, but it's not forgiving. It's ideal for users who understand friction management and have solid experience with rope systems. Now let's talk about escape devices. These are designed to be compact and lightweight, small enough to carry in a pocket or pouch, ready for life-threatening emergencies. Some of these devices are auto-locking and some are not. Their main purpose is rapid deployment. You want them accessible and simple to use when time is critical. Examples: Petzl EXO, Sterling F4. These devices are lifesavers in personal escape situations, but as with any rescue equipment, training is essential.
The event was January 23rd, 2005, a fire in the Bronx. Conditions got so impossible, they were forced to jump out the window of the 4th floor. 2 firefighters were killed, 4 of them were injured seriously.
As a professional firefighter, we're charged to risk our lives in many situations to save savable lives. During that time, you have to place yourself at risk. On occasion, you place yourself at a greater risk than you assume and become trapped inside of a structure on fire.
Conducting a search, conditions change rapidly. It's a high-risk situation. Fire conditions are such, they cannot get back to the means they came in.
Back in February 2005, the FDNY contacted Petzl to see if our Gree belay device used on the sports side could be used with 7.5mm rope and become the descent control device for their personal safety system. Tim Kelly and his committee worked with our product engineers at Petzl to create a new device that met their specification, now called the EXO. The EXO personal escape system is made up of an anchor hook with a hitching slot, a 50-foot 7.5mm Technora rope, an EXO personal escape descent control device, as well as a Nomex carry bag that is fastened to the firefighter's harness. Today, there are 40,000 firefighters who carry this system from 300 different fire departments from around the world. And we have been informed that the system has been deployed in several fireground situations.
The Mayday's taken care of, Mike. We're back off the 3rd floor, right?
The EXO is the most tested and carried personal escape system in the world.
The benefits of the EXO are the payout, which was a firefighter crawling from a remote anchor to the point of exit of the room, getting out over the edge, and then rappelling on it. Just releasing the handle, the firefighter was able to stop at a given point. If they had to aid in their own rescue, they could certainly do that.
When you're under duress, when your life is on the line, you default to your lowest level of common and consistent training. So the key with the EXO is it gives you the ability to perform skills when your fine motor functions have deteriorated under duress or because of the environment. It's easy to use, it's quick to use, and allows a smooth and rapid horizontal movement as well as egress once you're outside the window.
From day one, Petzl understood that training had to be an important part of this bailout solution. For those fire departments who want to offer their own training, Petzl and authorized trainers offer a 3-day train-the-trainer class, which allow you to train your own firefighters. Several fire departments that we have worked with in the past have been successful in obtaining grants from local, state, and federal sources. Petzl can help identify these grant agencies and sources.
We have 12,000 firefighters. We needed to see that every firefighter with a high degree of confidence could deploy and execute the PSS and perform a successful bailout under high-stress conditions.
It is a part of my turnout gear, and it's invaluable. I don't go anywhere within a structure on fire without the EXO attached to my side.
Just knowing that you have something in the event it goes very bad, having that PSS, for me personally, gives a high degree of confidence that if given that, I could get out the window and live another day.
Let's dive into non-autolocking escape devices. These are simpler in design, but there's no room for error. If you let go of the brake hand, they won't stop on their own. They're easier to feed and adjust quickly, which is helpful in a high-stress emergency. Their simplicity reduces the risk of jamming in a hurry. Skip 8. This is essentially a smaller figure 8, made for personal escape by firefighters in bailout situations. Works on single or double ropes from 7.5 mm to 12 mm. Additional wraps can be added for smaller ropes to increase friction. Lightweight and easy to carry, with a squared-off shape for better rope grip. The PMW hook is versatile. Can be a personal escape descender, a lowering device for rescue, or an anchorage connector. Comes in 2 sizes. To use, you take a bite of rope through the large hole and loop it over the neck, similar to a figure 8. Friction can be adjusted easily with extra wraps on the top part of the hook. So, whether autolocking or not, escape devices are specialized tools for life-saving scenarios. The key is knowing how and when to use them safely under pressure. Belaying is the process of protecting a person from falling by controlling the unloaded rope, commonly called the belay rope. This ensures that if the main line fails, the person on the rope is safely arrested. Belaying a rescue load is different from belaying a single person. Recreational climbing devices that work for a single body weight may not be adequate for rescue scenarios. Traditionally, climbers attach the belay rope directly to both the belayer and the person being belayed. The oldest method of belaying is the body belay, but it has limitations, which brings us to modern belay devices. With a body belay, the rope is wrapped around the belayer's body, usually the waist. The friction of the rope around the body helps control a fall. The fall force may cause the belayer to lose control. The belayer can be injured. The belayer may become entangled in the rope. If the fall is caught, the belayer must hold the person until they are secured. Due to these risks, modern rescue operations favor mechanical belay devices instead of relying solely on the body belay. NFPA 2500, 1983, addresses belay device standards. Time to talk about belay plates and some personal belay devices. These are some of the main tools we use to catch someone if they fall, and yes, even seasoned rescuers can get it wrong if they're not careful. Belay plates are classic. Picture a small metal plate with 1 or 2 holes. Sounds simple, right? That's because it is. You feed a bite of rope through the plate, clip it to a carabiner on an anchor, and when someone falls, the friction generated in the system stops the fall. Easy to rig, reliable, and surprisingly effective. You can even use a figure 8 descender as a belay plate for personal loads. Just poke a bite through the small hole, clip it to a carabiner, and boom, you're belaying. And here's the best part, no rope twist. That's a win. Now, let's talk air traffic controller devices, ATCs, by Black Diamond, and similar personal belay devices. These guys are versatile and lightweight. Works with ropes 8.5 to 11 millimeters in diameter, perfect for rescue situations. Some devices even use a camming action, like the Beal Birdie, to help control descent. Not covered by NFPA 2500, but still a handy tool for rescuers, especially if you might need to belay someone across a leading edge or while climbing. A word of caution, don't rely on them for heavy loads without testing first. What works for one person may not hold a rescue load of 2 or 3. Belay plates are simple, effective, and create friction to stop a fall. Figure 8s can double as belay plates for personal loads. Personal belay devices, ATC, Birdie, are great for rescues, but know the limits. Test everything before you ever rely on it in a real-life rescue scenario. Remember, even the simplest device is only as good as the rescuer using it. Your brain and prep are your best safety tools. Alright team, now let's talk about braking devices for belay purposes. This is where things get interesting, because belaying a rescue load isn't quite the same as belaying a single climber. First off, remember, no single device or technique fits all situations. What works for a 150-pound climber might not work for a rescue load of 250 pounds or more. One method you'll see in rescue operations is the twin-tensioned rescue belay. Instead of using a traditional belay device, you actually use 2 descenders. It distributes the load, gives you more friction, and adds a layer of redundancy. Then we have the Munter hitch, also called the Italian hitch. This one's classic and incredibly useful. All you need is a rope, an anchor, and a carabiner. No fancy devices. When properly tied, it can act as a personal belay system for low fall factors. Just keep in mind, it's less effective with heavy loads, but if you rig it right, friction from directional changes or pulleys can make it work. Key point, always follow your AHJ's guidelines when choosing a belay device or technique. Consider impact forces, fall distance, weight of the load, and the environment. Test under realistic conditions before trusting your life, or someone else's, to it. Belay devices and techniques vary, there's no one-size-fits-all solution. The twin descender method gives you redundancy and control. The Munter hitch is simple, versatile, and can work in emergencies. Always test your system under conditions similar to what you'll encounter. Bottom line, the best belay device is the one you know inside and out, and the one you've practiced with in realistic scenarios. Don't just assume it'll work under stress. You need confidence in your system before you ever put it to the test.
Alright, now let's talk about rope grabs and ascenders. These devices are designed to grip the rope, and they're used in a wide variety of rope rescue situations. Most are metallic and have a camming mechanism that locks onto the rope. They might look simple, but there's a lot to think about before you pick one for a rescue scenario. First off, you need to ask yourself a few important questions when selecting an ascender. What size rope is it made for? How strong is it, and how is that strength determined? Can you easily put it on or take it off with one hand? Does it have a secure safety catch so it won't accidentally come off the rope? Is it comfortable in your hand? And can you operate it while wearing gloves? These are the basics, but they're crucial for safety and efficiency. Rope grabs generally slide freely in one direction and lock in the other, which means they only work properly when oriented the right way on the rope. Using them incorrectly can create a false sense of security. Now, let's break down the types. Fall arrest rope grabs are something you might see in industrial environments or on towers. Some are meant for rope, others for cable, and most aren't easy to remove once they're on. They're intended to work with a fall arrest lanyard, and sometimes a force-absorbing lanyard. Devices like the Petzl ASAP are approved for rescue belay, but always follow the manufacturer's instructions. Make sure you attach these devices in the right direction. The arrow should point toward the anchor. Keep it as high as possible above you to minimize fall distance, and don't grab or squeeze the activation feature during a fall. It can interfere with the device working properly. Then we have rigging rope grabs. These aren't for fall arrest, but they're great for progress capture and other rescue rigging tasks. They're usually rated by NFPA for general use or technical use. Rigging rope grabs are often a clamshell style, meaning it takes 2 hands to install, and once they're on, they're very secure. The cam design maximizes contact with the rope while reducing rope damage, and it's less likely to clog with ice or snow. Finally, there are personal handled ascenders. Devices like the CT Quick Roll operate on the same basic principle as other rope grabs. They slide freely up the rope and lock when weight is applied downward. You typically use at least 2 at a time. One goes up while the other supports you, then you alternate to move up the rope. Some have handles, some are handleless, and some are mounted at chest level, like the Petzl Crawl, for ergonomic climbing. These are fantastic for ascending, but they're not meant for belaying heavy loads, and using them incorrectly can damage the rope under shock or high weight. The key takeaway here is that rope grabs and ascenders are versatile tools, but they're only as good as the way they're used. Always follow the manufacturer's instructions, make sure they're rigged correctly, and consider the load, the potential fall, and the environment. When used properly, they can make rope rescue safer and more efficient for everyone on the team.
New and improved. Some of the key features, it now has an indicator, so if we see the red mark, we know that it's not fully engaged. As compared to the older version, it had a wire that would hold the cam in place or keep it from being lost. Now we've got actually a metal arm on there that actually helps to hold it and direct it. Very easy to place on the rope, set it in. The attachment hole goes in and down. You can see in the motion there that I see the red. As soon as it's locked in place, the red disappears on both sides. The cam's now in place. So it fits really nicely on the rope. Still engages the same way. You can see that when it's engaged, I get that nice crook in the rope. That's what actually does the stopping. This is very rope friendly. So handy for haul systems because of the cam on it is very smooth, but because of the milled out area with inside and this cam, it means the rope will actually slip and grab, and that way we don't have to worry about desheathing the rope. The Petzl Rescue Sender.
This is the latest version of the Petzl handled rope grab. Most of us know this as an ascender, but since it can be used for other purposes, such as part of a haul system, most manufacturers and agencies refer to them as rope grabs. Although grabbing has recently developed some negative connotations, so I'm going to stick to calling it an ascender. Primary uses for the Petzl Ascension are as a component of a SRT ascending system, as a mobile or self-belay device, and for either pulling on rope or as a progress capture device in hauling systems. Basically a mechanical version of a Prusik hitch that slides when pushed up a rope, but grips when pulled down on the rope. The Petzl handled ascender has been around for many years and has gone through several design iterations. Like most handled ascenders, it's based on the original Jumar and allows easy attachment and detachment from the rope. It comes in a right and left-handed version that are anodized in different colors. The Petzl Ascension has an aluminum alloy frame with a plastic and rubber overmolded grip and a cast stainless steel cam. The latest version of this ascender has a few modifications, most of which are improvements. It's about 15% lighter than the previous version from Petzl, which was already one of the lightest handled ascenders available. Each ascender weighs only 165 grams. They also changed the attachment hole at the base of the handle so that it's now large enough to accommodate 2 carabiners. This allows you to attach both a lanyard or cow's tail as well as a foot loop directly to the ascender. The last significant change is that the cam is now cast from stainless steel rather than chrome-plated steel that was used on all previous models. At first I thought this was a great improvement, even though there wasn't much of a problem with corrosion on the earlier models. However, this change, which was made across all of Petzl's ascenders, has resulted in reports of accelerated wear on the teeth of the cam. Once the top couple of rows of teeth wear down, there's some potential for the ascender to slip when first weighted. These teeth now appear to be the thing that wears out first, and this may shorten the ascender's life. The Ascension is rated for a wide range of rope diameters from 8mm up to 13mm, but if you're over 140 kilograms or about 310 pounds, then the minimum recommended diameter is 10mm. It carries a number of certifications including CE and by extension UIAA, for personal protective equipment. It's also certified by UL, EAC, and NFPA. Some of these standards relate to its use in professional rope access work, but for this review, I'll focus on its use in recreational single rope technique, and caving in particular. It has a maximum working load of 4 kilonewtons, which is about 900 pounds of force. This would be hard to exceed in normal SRT, but it's probably good to know if you might use it as part of a haul system for cave rescue purposes. To attach it to the rope, you release the safety catch with your thumb and open the cam completely. Then place the rope channel around the rope and release the safety catch to engage the cam. The safety catch mechanism on the Ascension is one of the easiest to operate of any ascender, and as a result, it's one of the quickest to get on and off rope with one hand. The handle itself gives you something to hold on to, which also makes it easier to manipulate one-handed than ascenders like the Petzl Basic. The Ascension can be used as a component in almost any common vertical ascending system, including the Frog, Texas, Rope Walker, and Mitchell. A carabiner or my own should be used when attaching rope, cord, or webbing to the Ascension because of the small radius attachment point. As mentioned, there's enough room to attach 2 carabiners to the hole at the base of the handle. If crossing a traverse line or ascending a rope rigged at an angle, then either the tail of the rope should go through the lanyard carabiner, or a separate locking biner should be attached around the rope and through the hole in the top of the ascender. This reduces the likelihood of the ascender twisting enough to come off the rope, or pinching the rope in a way that may damage it. When using the Ascension, or any ascender with a lanyard or cow's tail, minimize any slack and never allow the ascender to be below the attachment point on your harness. Be especially careful when working close to the anchor. If a fall occurs when you are near the anchor or when there's slack in the system, it may increase the fall factor and therefore increase the forces applied to the whole system, and the ascender may be the weak point in that system. Ascenders should be inspected for safety on a regular basis, at a minimum once a year. Look for signs of cracks or corrosion in the frame, and especially the attachment points on the frame. Look for excessive wear on the rope contact areas, including the teeth of the cam. Check that the safety catch and its spring operate properly, and look for signs of wear on the axle and its rivet heads. You can clean ascenders with warm water and soap. Petzl recommends a maximum water temperature of 30 degrees Celsius, but for proper white nose syndrome decontamination, the equipment must be submerged in 55 Celsius water for 20 minutes. There are no materials in the ascender that can be damaged at 55 Celsius, so there should be no issues in following the U.S. Fish and Wildlife Service protocol. If the cam or safety catch becomes stiff, you can use a small amount of machine oil or graphite to lubricate them.
Hi, I'm Keith Lisinski with the Petzl Technical Institute. Here's a tech tip for the proper installation and removal of your ASAP and ASAP lock on a lifeline. The ASAP and ASAP lock mobile fall resters are compatible for use on Kernmantle ropes from 10 to 13 millimeters in diameter. Let's take a look at the installation of the ASAP. To start, begin by disconnecting your connector from the frame of the ASAP. With your free hand, place a small amount of downward tension on the rope. With the up arrow on the frame of the ASAP pointing towards your anchor, tilt the top of the ASAP towards the rope. Press this textured portion of the arm against the rope, and with an upward and inward motion, slide the ASAP onto the rope. Once the ASAP is free to move up and down, reinstall your connector onto the frame, making sure to capture the rope between the frame of the ASAP and the connector. To perform a function check, quickly pull down on the ASAP. To unlock, place your thumb on the locking wheel near the Petzl logo and press the locking wheel into the rope. Slide the ASAP up the rope until you hear a click, and the ASAP is free to move up and down the rope. To remove the ASAP from the rope, disconnect the carabiner from the frame of the ASAP, and again place a small amount of downward tension on the rope, while you slide the ASAP up and tilting the top of it away from the rope. Let's take a look at using the ASAP lock. To start, we'll open the locking wheel by pinching these two safety catches with your thumb and forefinger. Note that if you pull down on only one of the safety catches, the locking wheel can't open. Pinch both safety catches and pull them down and away from the device until they hold on to the frame of the ASAP lock, keeping the locking wheel in an open position. Next, insert the rope into the rope channel of the ASAP lock with the up arrow pointing towards your anchor. Snap the safety catches downward, capturing the rope between the locking wheel and the frame. Before performing a function check, ensure that the locking button is not in the locked position. To perform the function check, quickly pull down on the frame of the ASAP lock. To unlock, press the locking wheel into the rope and slide the device upwards. Again, until you hear a click and the device is free to move up and down the rope. To remove the ASAP lock from the rope, simply repeat the process of pinching both safety catches and pulling them downward and out until they hold onto the frame of the device. Then simply remove the rope from the rope channel. These were just a few tips on the proper installation and removal of your ASAP and ASAP lock mobile fall arresters. For complete information, please visit petzl.com and refer to the instructions for use and tech tips.
Hello, I'm Olivier Lamy. I'm a trainer at V-Access, the Petzl Institute. I'm going to introduce the new Grillon lanyard. It's a positioning lanyard which allows you to get comfortably positioned at your workstation and which must be combined with a fall arrest system. Two major new features are that there is a handle on all the positioning lanyards and that according to the specifics of the workstation, it's possible to remove the protective sheath. The Grillon work positioning lanyard is composed of a semi-static rope, two plastic protective sheaths with sewn terminations, a removable protective sheath, and a self-blocking device. The Grillon lanyard can be used in two ways, in single or in double mode. In double mode, the user is standing on his feet. He chooses an anchor at hip height and uses a Grillon lanyard on the lateral attachment points. This allows a good load distribution on the waist belt. The removable sheath protects the lanyard from abrasive contact and provides smooth rope glide. The length is easy to adjust. To shorten the lanyard, just pull on the rope. To lengthen, just press on the cam. For use in single mode, the user is standing on his feet. He chooses an anchor at a high point. He attaches his lanyard to his ventral loop to have good weight distribution across the waist belt and thighs. With the handle, the user may progressively release the rope. In this case, he must always hold the free end of the rope. If the user needs to come as close as possible to the anchor, he may take off the removable sheath. There are several versions: 2 meter, 3 meter, 4 meter, and 5 meter.
Now let's talk about anchorage connectors, which are really the foundation of any rope rescue operation. Making a proper connection to a sufficient anchorage is critical. Everything in your system relies on it. Anchorages themselves can be natural, like trees or rock formations, or they can be part of existing structures. Sometimes we even install them as needed, depending on the scenario. The method you use to attach your system to that anchorage will directly affect how well it performs. And don't overlook the connecting components themselves. They need to be strong enough to handle the forces you anticipate, and they must be attached in a way that prevents unwanted movement or the system coming loose. In short, your anchors are only as good as both the anchorage and how you connect to it. Next up, anchor slings. These are the straps or loops we use to tie into an anchorage quickly and reliably. They come in a few different materials: webbing, rope, or metal D-rings, and many include sewn loops or carabiner attachment points. Anchor slings are a fast way to establish a dependable anchor, and they're built in two main types. Heavy-duty slings, designated G by NFPA, can handle around 8,000 pounds. Lighter weight slings, designated T, are rated at just under 5,000 pounds. Both are strong enough for most rescue operations, but you choose based on the load and scenario. Slings also have different features. You can increase their strength by rigging them in a basket configuration. Some come with a choker option using a larger ring at one end. Others have built-in pads to protect the strap, or buckles that let you adjust length, though you have to remember that under load, buckles can slip before reaching the rated strength. Knowing these details ensures you can pick the right sling for the job. Finally, let's look at pre-sewn slings, which offer a lot of versatility in rope rescue. These are usually sewn into a circular loop and can serve as an anchor sling or be adapted for other purposes. When selecting a pre-sewn sling, you need to consider a few things. Make sure it has adequate tensile strength for the safety factor you need. If abrasion or cutting is a concern, steel anchor straps are a great option because they resist wear and provide extra protection. For fall protection, steel cables with swaged loops at each end are often used. Strength ratings for most of these slings hover around 5,000 pounds, but by using multiples, you can construct an anchor capable of handling heavier loads safely. And don't forget to check your AHJ requirements. They may have rules about sling length, width, weight, material, adjustability, termination type, or even color. Considering all of these factors will help you set up reliable, safe anchors every time. Let's move on to beam clamps, which are really useful in industrial and urban rescue environments. These locations often present a unique challenge for anchors. Angular steel beams can be tough to wrap slings around, and the edges can be destructive to webbing or rope. Plus, the sheer size of these structures sometimes makes it difficult to secure a traditional anchor. Beam clamps give us a solution. They provide safe anchor points right on the structure itself. While a single beam clamp may be rated around 5,000 pounds, which might feel a little light for a full rescue, using multiple clamps together can create a very strong, reliable anchor system. The key takeaway here is that multiple properly placed anchor points can work together to give you the strength you need, even in challenging industrial settings. Next, let's talk about bolt anchors, which are often found in industrial sites and urban structures. These are pre-engineered fall protection anchors, usually installed in areas that workers access frequently, like confined space entry points, tanks, vaults, or other work surfaces. Before using any bolt anchor, it's critical to make sure it's rated for life safety. Many fall arrest anchors are only rated for about 5,000 pounds, and positioning anchors can be even lower, around 3,000 pounds. That means sometimes you'll need to use 2 or more anchors together to achieve the strength required for a rescue. Bolt anchors come in different designs. Some are fixed in place, while others can swivel. You also have removable anchors that might be used in concrete or steel structures, and their strength and performance vary depending on the quality of the material they're installed into. Ultimately, it's the rescuer's responsibility, under the guidance of the AHJ, to make sure that the anchors you choose are adequate and appropriate for the rescue loads. You can't just assume that because an anchor is installed, it's safe for your specific rescue scenario. In some rescue situations, you won't have a natural or structural anchor available, and that's when portable anchors, also known as artificial high directional, become an essential tool. Devices such as tripods and the more advanced multipods can provide an excellent solution, but they do require proper training to use safely and effectively. Before deciding to deploy a portable anchor, it's important to base that decision on a risk assessment, considering the environment, the type of rescue, and the team's capabilities. Factors like the number and type of head attachments, the height and strength of the unit, and any optional accessories all play a role in determining which system is best for the situation. Tripods and multipods can be bulky, so packaging, storing, and transporting them requires careful planning. Once on scene, it's critical to keep all components together and ensure that your team can assemble and deploy the system quickly. Advanced concepts, like the Arizona Vortex or the TerrAdaptor, show just how versatile portable anchors can be. The TerrAdaptor, for example, can be configured as a monopod, bipod, tripod, or even a quadpod, and it can be combined with additional units to create virtually limitless high-point configurations. It's adjustable in height from 4 to 12 feet, and with the right attachments, it can adapt to any terrain. Whether used as a high point for lifting a rope system off the ground, as an anchorage, or as a change of direction, portable anchors expand what a rescue team can achieve in environments with no fixed anchor points. Another option for creating anchors in environments where no natural or structural points exist is the picket system. Pickets are particularly useful in natural areas, but they come with their own set of challenges. Establishing a picket anchor properly takes time, and the type of soil will determine how effective the system is. Loose, sandy, muddy soil or snow may not hold pickets securely, no matter how many you use. Pickets must be made from materials strong enough to withstand the forces of a rescue operation, with good shear strength to resist bending or breaking. Most picket systems consist of several rows of stakes driven into the ground in a specific configuration to create a stable anchor. When done correctly, these systems can provide a secure and reliable anchor point, but they require careful assessment and proper construction to ensure they will hold under load. Pickets are a reminder that even in the absence of natural or structural anchors, a well-trained team can improvise and maintain the safety and integrity of the rescue system.
When we're talking about building our picket fields for our anchoring system, there's a couple variables that go into play. The biggest one of those being the soil type that you're driving your pickets into. Here in Ohio, typically we have a clay, loamy type of soil. And when we drive pickets, we're typically going to use either 1-inch rolled steel or 1-inch rebar. When we drive these, there's several different variations you can use to build a picket field. As you see in our application here, we have what's called a 2-to-1 picket system. In that configuration, you're typically going to get about 2,000 pounds of anchor stability with the 2-to-1 system. If you go to a 1-to-1, you're typically about 1,400 pounds. And if you go a cluster of 3 to a cluster of 2, back to a cluster of 1, you're typically going to get around 4,000 pounds of anchor stability. When you drive your pickets into the ground, again, you want to articulate them about 15 degrees away from your load, and you want to drive them about 2/3 the depth. So in this application, we have 4-foot rebar. We've driven it roughly 3 feet into the ground, leaving us enough room up here to where we can do our Spanish windlass, which is going to be our tie back from our cluster of 2 back to our single piece of rebar. We're talking about spacing when we do our picket fields. Typically, we're using 4-foot 1-inch rebar to build our pickets. So spacing, once we drive our initial picket, we're going to take our second picket and lay it down from front to back, and that'll give us our 4-foot spacing to drive our second picket. We'll also do that as we go laterally as well. We'll take that same 4-foot piece of rebar, lay it out laterally, and that'll give us our roughly 4-foot spacing between pickets. Okay, when we tie our pickets together, or back tie our pickets, we want to use what's called a Spanish windlass system. What we're going to use here is 10 mil utility rope, and we're going to start off with a clove hitch, and we're going to go about the middle height of the initial group of pickets. What we want to do is we want to wrap this from the front group of pickets back to our single picket. When we do that, we want to kind of mimic that 15 degrees of articulation. So we're going to start out to the middle of this one and come back to the bottom. That's going to get us roughly perpendicular on the front group of pickets. Then we're just going to take and we're going to continue to wrap this a minimum of 3 times. Then once we get to the end of our rope, we're just going to go ahead and finish it off with another clove. Once we get that on and snugged up, we'll go ahead and finish it off with a safety. So we have our cord wrapped on there, and we're ready to tension these two systems together. What we're going to take, we have a 18-inch concrete stake here. You can use 1-inch rebar as well. What you want to do is you want to put it down in between your ropes, and you want to tension this just to the point you start seeing deflection. Your front group pulling backwards and your rear single one pulling forward. So we'll just wrap this a few times until we see that deflection right there. Once we see that deflection, we're just going to take and drive this stake into the ground just to keep it from untwisting. Once at the end of the ground, I'm going to pull up, make sure that's not going to pull the keeper out of the ground. And there you have your Spanish windlass built on your picket system.
In rope rescue, pulleys are primarily designed to reduce friction on a rope, but their usefulness goes far beyond that. Pulleys allow rescuers to change the direction of a running rope, position a rope more conveniently, and reduce abrasion. For instance, a pulley can lift a rope away from an edge or other surfaces, preventing wear and prolonging the rope's service life. They are also key components in mechanical advantage systems, helping rescuers lift or lower loads more efficiently and safely. NFPA 2500 from 1983 classifies pulleys into 2 categories: technical pulleys, labeled T, and general pulleys, labeled G. When choosing pulleys for a rescue team, the authority having jurisdiction, or AHJ, should consider several factors. Efficiency is important. Ball-bearing pulleys are more efficient than bronze bushing pulleys but do not handle sudden shock loads as well. The configuration also matters. While double pulleys work well for 2 lines following a common rope path, they should not be used as a single pulley. For systems using a Prusik hitch as a progress capture device, a Prusik minding pulley should be selected to prevent the hitch from jamming. Size and overall dimensions should be balanced with portability. The sheave width and diameter affect performance, with rescue pulleys typically available in 1/2 inch or 5/8 inch widths. Selecting a pulley with a sheave diameter at least 4 times the rope diameter helps maintain efficiency. Pulley strength should correspond to the rope strength, with steel side plates generally stronger than aluminum. Compatibility with the rope is critical. Smaller ropes can run on larger sheaves, but larger ropes must never be forced onto smaller sheaves. Movable side plates allow pulleys to be placed anywhere along a rope, and extended side plates help protect the rope during use. Specialized pulleys also exist for particular applications. Knot-passing pulleys have large sheaves so knots connecting rope segments can pass through without getting stuck, making them excellent for high lines. These pulleys can also handle multiple ropes simultaneously and, when fitted with locking pins, serve as strong tie-off points. Prusik minding pulleys are designed with squared-off side plates that hold a Prusik hitch open, preventing it from jamming or being sucked into the pulley, which allows the hitch to slide freely while still providing control. Understanding these characteristics and selecting the right pulley for the task is critical to creating safe, efficient, and effective rope rescue systems. In rope rescue, a variety of hardware is used to make systems safer, more efficient, and easier to manage. One important piece is the rigging plate. Rigging plates serve as collection points for multiple anchors or rigging lines, helping rescuers keep complex systems organized. They offer several benefits. They save time when setting anchors, help rigging personnel visualize the setup quickly, and add an extra layer of safety by reducing confusion at critical points. Rigging plates are commonly used wherever multiple lines come together at a single point. This could be at an anchor, at the master attachment point on a litter, or anywhere several anchor lines converge. When selecting rigging plates, it's important to choose ones that are strong and NFPA rated, typically designated as G for general use. Contoured edges are also important to prevent damage to ropes and carabiners, and the hole should be large enough to accept even the largest locking carabiners without difficulty. Another valuable piece of hardware is the swivel. Swivels are used in rope systems to prevent rope and equipment entanglements. They are particularly effective at reducing torque or unwanted spin in a system, helping maintain smooth operation and reducing wear on ropes and hardware. By incorporating rigging plates and swivels into rescue setups, teams can manage multiple lines more effectively while improving overall system safety and efficiency. Proper care of rope rescue equipment begins with thoughtful storage. Equipment should always be kept in a clean, dry area, protected from exposure to chemicals, fumes, or other substances that could degrade its performance. Using bags or containers not only secures the gear but also makes it easier to carry and deploy when the situation demands it. Before storing equipment, it's essential to follow the manufacturer's instructions for cleaning and preparation to ensure longevity. Inspection and record keeping are key parts of maintaining a safe rescue program. Rescuers should always be alert for signs of wear or damage, but relying on informal observation alone is not enough. Establishing a regular inspection program ensures that equipment remains reliable. Inspections should occur before placing gear into service, before each use, and at routine intervals. Creating a detailed log for each piece of equipment helps maintain traceability and ensures that no critical items are overlooked. Before using any rope rescue equipment, a pre-use inspection is essential to confirm that it is safe and ready for operation. This inspection combines both visual and tactile checks. Rescuers should look for frayed ropes, worn stitching, or any damage to hardware, while also feeling components for hidden weaknesses that may not be immediately visible. Timing is important. Many agencies perform this inspection as they are removing gear from storage, but it can also be done as equipment is being returned from previous operations. The goal is to catch issues early and prevent failure during a critical rescue. Equipment should meet all criteria for safety, including being free of animal damage, pinches, or other mechanical wear. Every rescuer has a responsibility to ensure that their gear is safe for use before it enters the system. Regular, thorough inspections go beyond pre-use checks and provide a deeper look into the condition of rope rescue equipment. There is no single correct interval, but most organizations schedule detailed inspections at least twice a year, while high-use teams may inspect gear monthly. These inspections are time-intensive, focusing on every component, including hardware, stitching, moving parts, and any accompanying records or logs. Detailed records of these inspections are critical for accountability and for ensuring that equipment remains in compliance with standards. By maintaining a consistent inspection schedule, rescuers can identify problems before they become safety hazards, prolong the life of their gear, and ensure that every piece is ready when it is needed most. Inspecting rope rescue equipment properly requires more than simply knowing what to look for. It starts with following industry best practices and the manufacturer's instructions, but also demands careful consideration of the specific context in which the gear is used. For example, each piece of equipment may be exposed to unique hazards, environmental contaminants, or extreme conditions that could affect its integrity. While a rescuer can be trained to identify issues visually and through touch, making informed decisions about continued use or retirement is subjective and requires experience. Expertise in inspection is developed over time, ideally under the guidance of a competent, experienced mentor. During a thorough inspection, several contextual factors should be considered alongside visual and tactile checks. This includes any known information about the product, its age, the purchase date, and its usage history. Ultimately, lives can be saved by adhering to the simple but critical principle: when in doubt, throw it out. When inspecting soft goods such as ropes, slings, or webbing, The mnemonic T-SHAPS provides a useful framework to guide a comprehensive inspection. T. Thermal. Look for thermal damage, which often appears as glazed, charred, or hardened fibers. Feel for areas that are stiff or overly smooth, which could indicate heat exposure. C. Contamination. Check for discoloration, unusual stiffness, softness, or even odors that may indicate chemical or environmental contamination. H. History. Review the usage log carefully. Ropes used more frequently, under heavier loads, or in harsh conditions may need earlier retirement. Age. All fibers degrade over time. Factor in the rope's age along with its history and your visual/tactile inspection to determine its remaining service life. P. Physical damage. Examine for cuts, abrasions, tears, bulges, hourglass shapes, or fuzzy sections. Both looking and feeling for damage is critical. S. Soiling. Heavy dirt may not directly damage the rope, but it can obscure other problems and indicate possible contamination. Using T-SHAPS ensures a methodical inspection that leaves no stone unturned when assessing the safety of soft goods. For hard goods such as carabiners, pulleys, and descenders, the mnemonic academic guides the inspection process. A. Alignment. Is the item properly aligned as manufactured? C. Cracks. Look for visible hairline cracks, especially at connecting points. A. Action. Does the device operate smoothly without sticking or jamming? D. Deformation. Check for bends or warps in the body of the item. E. Edges. Inspect for sharp or excessively worn edges along rope paths. MI. Missing. Ensure no subcomponents are loose or missing. C. Corrosion. Look for rust or corrosion, particularly at joints or moving parts. While age is generally less of a concern for metallic items than for soft goods, all inspections should consider any manufacturer-stated maximum lifespan or obsolescence date. Equipment that fails inspection should be removed from service immediately. Retired gear must be destroyed or rendered inoperable to prevent accidental reuse. In some cases, minor modifications may be acceptable, such as cutting out a damaged section of rope, but only if the remaining equipment is unquestionably safe and fully functional. Following these principles ensures that all equipment in use is reliable and safe for the high-risk environment of rope rescue. We've covered an overview of rope rescue equipment and its proper use, inspection, and maintenance. Let's recap the key points. An established rope rescue equipment program ensures that the right tools are in working order and ready for rescuers to utilize in an emergency. This program provides clear guidelines on equipment selection, inspection, maintenance, and documentation. Selecting rope rescue equipment begins with identifying the type of emergency to which responders may be called. Rescuers should understand the specifications of each piece of equipment and how those specifications relate to its intended use. NFPA 2500/1983 sets the baseline performance requirements for rescue gear. However, the authority having jurisdiction, AHJ, has the final say on the appropriateness of equipment for their teams. Equipment is classified into 3 ranges: G. General, T. Technical, and E. Escape. Carabiners are a fundamental piece of rope rescue hardware. They are categorized as G or T and are made of aluminum alloy or steel. Common shapes include D, modified D, and pair/HMS. It's important to remember that a carabiner's strength varies depending on the direction and configuration in which it is loaded. Other connectors include triangular or semicircular screw links, which are used where smaller dimensions or compact designs are desirable. Braking devices help control the rate at which a load is lowered or a rescuer descends. These include autolocking and non-autolocking devices, and NFPA classifies descenders into E, T, and G categories. Belaying is critical for protecting a person from falling by controlling an unloaded rope in a way that secures the individual if their primary support fails. Rope grabs are devices, usually metallic, with a camming mechanism designed to firmly grip a rope, adding another layer of safety. Anchorages can be existing structures, natural elements, or purpose-installed systems, and are essential for safely securing ropes. Portable anchors, like tripods or multipods, expand rescue capabilities when natural anchors aren't available. Pickets serve as alternatives in soft soil or remote areas. Pulleys are designed primarily to reduce rope friction, but they also Change the direction of a running rope. Position a rope in safer, more convenient locations. Reduce rope abrasion. Develop mechanical advantage in hauling systems. Other hardware, such as rigging plates and swivels, help organize multiple lines and prevent entanglements. Finally, maintenance and inspection are essential. Follow manufacturer instructions for cleaning, storing, and inspecting equipment. Perform pre-service, pre-use, and regular inspections, and adhere to best practices for identifying damage or wear. When in doubt, follow the maxim, when in doubt, throw it out. By implementing these standards, your rope rescue team will be prepared, safe, and ready to respond effectively to any emergency situation.